I want to spend some time covering what you'll learn after completing the Introduction to Engineering course. First though, I want to attempt to answer the question, what is engineering? And then summarize the various engineering disciplines taught here at IUPUI. There are many definitions and explanations of what engineering is. Google defines engineering as the branch of science and technology concerned with the design, building, and use of engines, machines, and structures, the work done by or the occupation of an engineer, the action of working artfully to bring something about. Continuing on, ABET, which is an acronym for Accreditation Board for Engineering and Technology. And it's important to know that the programs here at IUPUI are ABET accredited, so that's very important for you in your engineering career. The ABET definition for engineering is the profession in which a knowledge of the mathematical and natural sciences gained by study, experience, and practice is applied with judgment to develop ways to utilize economically the materials and forces of nature for the benefit of mankind. Contrasting engineering with engineering technology, they explain engineering technology as the part of the technological field that requires the application of scientific and engineering knowledge and methods combined with technical skills in support of engineering activities. And engineering technology lies in the occupational spectrum between the craftsman and the engineer at the end of the spectrum, and it's closest to the engineer versus the craftsman. The Wikipedia definition of engineering is the application of mathematics, empirical evidence, and scientific, economic, social, and practical knowledge in order to invent, innovate, design, maintain, research, and improve structures, machines, tools, systems, components, materials, and processes. Also, the discipline of engineering is extremely broad and encompasses a range of more specialized fields of engineering, each with a more specific emphasis on particular areas of applied science, technology, and types of application. So, one of the disciplines is mechanical engineering, taught at IUPUI. Mechanical engineering is a branch of engineering concerned primarily with the industrial application of mechanics and with the production of tools, machinery, and their products. The branch of engineering dealing with the design and production of machinery. Mechanical engineering is the discipline that applies the principles of engineering, physics, and material science for the design, analysis, manufacturing, and maintenance of mechanical systems. An engineering field which requires an understanding of core concepts including mechanics, kinematics, thermodynamics, material science, structural analysis, and electricity. And mechanical engineering uses core principles along with tools like computer-aided design, product lifecycle management to design and analyze manufacturing plants, industrial equipment and machinery, heating and cooling systems, transport systems, aircraft, watercraft, robotics, medical devices, weapons, and others. So mechanical engineering is certainly a very broad field, as you can see here. Electrical engineering is a field of engineering that generally deals with the study and application of electricity, electronics, and electromagnetism. It's a branch of engineering that deals with the technology of electricity especially the design and application of circuitry and equipment for power generation and distribution, machine control, and communications. Electrical engineering has now subdivided into a wide range of subfields, of course, as electronics and electricity becomes more and more propagated through all fields of engineering, including electronics, digital computers, power engineering, telecommunications control systems, radio frequency engineering, signal processing, instrumentation, and microelectronics. The subject of electronic engineering is also often treated as its own subfield, but it intersects with all other subfields, including the power electronics of power engineering. And this is a field that I am heavily involved in at this present time in my engineering career. Computer engineering is a discipline that integrates several fields of electrical engineering and computer science required to develop computer hardware and software. Computer engineers usually have training in electronic engineering or electrical engineering, software design, and hardware-software integration instead of only software engineering or electronic engineering. So they're required to know both. Computer engineers are involved in many hardware and software aspects of computing, from the design of individual microcontrollers, microprocessors, personal computers, and supercomputers. It's a field of engineering that not only focuses on how computer systems themselves work, but also how they integrate into the larger picture. The usual tasks for computer engineers include writing software and firmware for embedded microcontrollers, designing VLSI, which means very large scale integrated chips, designing analog sensors, designing mixed signal circuit boards, and designing operating systems. Computer engineering is suited for robotics research, which relies heavily on using digital systems to control and monitor electrical systems like motors, communications, and sensors. Software engineering is the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. Research, design, develop, and test operating systems level software, compilers, and network distribution software for medical, industrial, military, communications, aerospace, business, scientific, and general computing applications. Software engineering is the systematic application of scientific and technological knowledge, methods, and experience to the design, implementation, testing, and documentation of software, and the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. And lastly, biomedical engineering, which is taught at IUPUI. It's a discipline that advances knowledge in engineering, biology, and medicine, and improves human health through cross-disciplinary activities that integrate the engineering sciences with the biomedical sciences and clinical practice. This field seeks to close the gap between engineering and medicine by combining the design and problem-solving skills of engineering with medical and biological sciences to advance healthcare treatment, including diagnosis, monitoring, and therapy. Biomedical engineering applications include the development of biocompatible prostheses, various diagnostic and therapeutic medical devices, ranging from clinical equipment to microimplants, common imaging equipment such as MRIs, EEGs, regenerative tissue growth, pharmaceutical drugs, and therapeutic biologicals. So Now that the question of what is engineering has been addressed, let's take a look at the skills that you'll develop in Engineering 196. First of all, you'll learn how to create solid models using Creo software. This will be an important skill for you at IUPUI, as you can use this skill to develop designs for other courses, including senior design. Other solid modeling software programs are similar to Creo, and the ability to use these programs for design is very much valued by employers. It's a very good thing to include this on your resume if you can. You'll learn how to use multi-sim circuit analysis software, which can be used to solve homework problems in courses such as ECE 201 and ECE 202. The ability to use these programs is valued by companies and also looks good on your resume. In writing the lab experiment reports, you'll improve your technical writing skills. This is very important since reports need to be written for other IUPUI courses, and the ability to document test results in a clear manner is always important for all engineers. The project presentation will help you develop your skills in making PowerPoint presentations. Presentations will be needed in other courses at IUPUI, and you'll most surely need to make presentations throughout your engineering career. You'll improve this skill every time you do it. In completing the electronics lab experiments, you'll be using various lab equipment that will also be used in ECE 207 and 208 labs. The ability to use electronics test equipment is useful for electrical, computer, and biomedical engineers, and is a good thing to include on the resume for all engineers. And you'd be surprised that not that many engineers really know how to use this electronics test equipment. And then by using C programming and microprocessors, you will become familiar with them and how they can be applied to projects such as senior design. An understanding of and the ability to use microprocessors is becoming an increasingly important skill in engineering.